Okay, we're going to look at Solver here. Solver is something that a tool that helps you maximize a profit by changing other values, or minimize a loss by changing values, or reach a precise figure by changing other values in other cells. Here is the spreadsheet for the Slick City clothes rentals, and we have branches in Newark, Wilmington, Dover, Lewis and Rehoboth Beach, and we sell white tuxedos, black tuxedos, or we rent them, and suits. We're having a problem with the suits. We want to see if we can maximize our profit here by changing the amount of suits that we sell. Okay, now we use Solver for this, which you can find under Data, and Solver is there. If it's not there, you have to install it from a file in the options. I'm not going to do that now. So I bring up Solver, and we get this interface. So you can see there the initial profit is 17,893. So I've noted that below there, so that if we do manage to make Solver work, we can see if it has brought us increased profit. So the objective is to maximize that profit by changing the suit sales. So we have to then go and highlight the cells with the suits in. Okay, not the total, just the different places. So we're happy now. Let's go and run the Solver and see what happens. Oh, there's a problem, and I'm not going to accept this answer. So we are actually going to make a lot of money. It's great. If we increase our sales of our suits to something that won't even fit in the space available, we can turn a profit of, what's that? $134 billion. It doesn't take a genius to work out that that's not going to happen. So we cancel that. We have to put in some constraints, which are listed here. We know our Newark shop is unlikely to be able to rent more than $3,000 worth of suits, no matter what we do. Wilmington, maybe we can get away with 2,000. We know we can do 2,000, but we may be able to get up to 4,000, but not beyond that. Dover, well, we probably can get 1,000, but 1,500 is going to be pushing it, so we'll have those constraints there. Everything else, Lewis, Rehoboth Beach, we're not going to reach 1,000, but we'll put the maximum as 1,000. So we have to put in some constraints. This is how we do it. We bring back up Solver, and it remains the same. So there's this area here for adding constraints. We want to add the constraints in the order that they're listed here. So the first one is Newark is going to be, so we have to go and find Newark and click on the suit square, and that is going to be less than or equal to, which is the default setting here, 3,000. So there we go. We can either go back to the main menu and then add another constraint, or nice and handily we can just click on add and we move to the next one. So we're done with Newark, but Wilmington and Dover each need 2 constraints, and we start with the low one and then we put the high one in. So we want Wilmington suits to be greater than or equal to 2,000, and Wilmington suits to be less than or equal to 4,000. Moving on, we want Dover suits to be greater than or equal to 1,000, and we want Dover suits to be less than or equal to 1,500. See the less than sign. Okay. Next we want Lewis suits to be less than the default setting, 1,000, and finally, we want Rehoboth Beach suits to be less than or equal to 1,000. We can now choose OK, and there they all are that we've put in. And now we just click solve. So let's have a quick look at the profits first. Currently, it's 17,893, and the suit profit is 5,000. Well, the suit income is 5,239. So let's just hit solve and see what happens. Thinking about it, there are no problems. We've got to keep the solver solution. We'll click OK. So we can close that for now. So our profit has gone up from 17,893 to 23,154, which is pretty good. And we've done that by, what's happened is, of course, because we want to maximize our income, everything's gone to the maximum value that we could have set. But it's with it, because of the constraints, we're not selling billions of suits. We're selling or renting a manageable number of suits within manageable aspirations. So that's Solver.